In this collection of videos, we are going to introduce looping. So what is looping? Why do we need loops in computer science? Well, occasionally there's some sort of portion of code that we might want to do many times over again in a program. So for example, we recently learned about the turtle module and importing that in order to create some shapes and visuals inside of Python. And one thing we might want to do is create a square. And in order to do that, we had to use the forward commands in the turtle module and the right turn commands in the turtle module numerous times. One thing that we could use loops for is instead of typing over forward right, forward right, forward right, forward right 4 times, looping would help us to not have to write this many lines of code, but to end up creating the same thing. So that's an example that we'll see later on. Another reason we might want loops is we may want to do a certain task until a condition is met. For example, a question you might have had when we were writing previous programs, one of the things we would do is we would check user input for valid data. For example, when we were writing a parking program that determined the cost of parking for a particular number of hours, we did not want to use a formula if the user accidentally entered in a negative number of hours. So what our program did in that situation is asked for the number of hours, and if the user gave us invalid data, we just didn't execute any more code. A better strategy would have been to tell the user that they entered incorrect data, assume that this is a mistake, and prompt them to re-enter some valid data. And we could do that as many times as we needed to until the user entered some correct data into our program. And that would have been a much better way to approach the problem other than just only allowing them that one mistake and exiting out of the program. Last but not least, one of the things we might want to do is create what's called a wrapper, where we put a loop around a program which lets the user run the whole program more than one time. For example, when we wrote code to compare the cost of 2 different cars, one of the things we did is prompt the user for a gas price, and we discussed how the user might want to enter in multiple different estimates for gas price over the course of time in order to get a range on how long it might take them to make up the cost of the car. Instead of having our user run the program closes, and then we rerun the program all over again, we could put a wrapper loop around the whole program, and at the very end of the program say, would you like to run the program again? And then the program would restart from the beginning without our user having to close the program down and then restart it on their own later on. So these are all examples of times that we might want to use loops when writing our computer programs. Let's be a little bit more precise about what a loop is. A loop, similar to our branching statements, is a control structure that allows certain blocks of code to be repeated either a known number of times or until a particular condition is satisfied, often an unknown number of times. So similar to a branching statement, a loop is going to break the flow of control so that we no longer execute code sequentially, but in a different manner. The 2 different types of loops that we'll be studying for Python is something called a for loop, and a for loop is for when we want to repeat a particular process a known number of times, where we know the number of times we will need to repeat that process in advance. And the other type of loop we'll be learning about is called a while loop, which is for repeating a process an unknown number of times, where in advance we do not know how many times that portion of code will need to run. It's a different sort of condition controlling how often we'll need to execute that code. Let's begin with talking about for loops and looking at an example. For loops are for where we wish to execute the code a certain known number of times in advance. The syntax for using a for loop, again we'll see an example in just a moment, is to use the reserve word for. Then what we'll have is a variable name. Often we use the letter I, but there's no rule for that. The variable name is followed by the reserve word in. We then also use this word called range, which is going to create for us the numbers 0 up through the number num times. And what is in essence going to happen is we are going to create a variable with this particular name, and we will start by assigning it the value of 0. Then the things that need to be repeated will be executed one time, and at the very end we will return back up to this line of code, and that variable that we've created will be reassigned the next value in the range. So after being 0, it will switch over and become 1. And we will continue this process num times, executing this chunk of code, and then reassigning the value of variable name to the next sequential number in this list. And the number one reason that we tend to use for loops is to make our code more readable, and it is a much better programming practice than copying and pasting. Copying and pasting works when you need to do something maybe 4 times, like creating a square, but you would get really tired of that if you had to do a task, say, 100 times. But a for loop would be able to create that code in just a couple of lines, making your code much more readable. And one of the biggest fears with copying and pasting is if you haven't done it correctly the first time, and then you copy and paste it over and over and over again in your code, then you will need to change and fix that mistake over and over and over again in your code. When you write the code to be done inside the block of a for loop, if there's a mistake, you only need to change it in one location, and that makes your life as a programmer much, much easier. So let's see an example of a for loop using the turtle module that we studied last time. So let's imagine that we'd like to draw an octagon. The key components of drawing an octagon is that our turtle will need to move forward, and then our turtle will need to turn a particular amount. Since we want to draw a regular octagon, the amount that the turtle needs to move forward, 50 units, will be the same every single time. Additionally, the amount that the turtle will have to turn to its right will be the same every single time. It will need to turn 360 degrees divided by 8, since that's the number of sides in an octagon. So instead of writing turtle.forward 50, turtle.right 360 divided by 8, instead of writing that once and then copying and pasting it 7 times and filling up all of this chunk of code, what we can do instead is write the reserve word for. Then we need to create a variable. I've used the variable I. This I is sometimes called a dummy variable, or I is used for iterator because we want to iterate through a range of possibilities. So for I in, then we use this word range and the number of times that we want to execute this code. And what will happen is our flow of control will first read line 1. Second, it will hit line 3. It will create this variable I, started at 0. It will then execute line 4 and line 5. And once the code has completed line 5, it will come back up, and in place of line 3, I will change from 0 to 1, and it will run this code again. And it will keep doing that until I has taken on the last value in the range, which here will be 7, something we'll talk about a little bit more later on. So it will go 0, 1, 2, 3, 4, 5, 6, 7, which is a full 8 times. And this will be completed 8 total times. So you can see what happens when we run. The turtle goes around and it stops. Now, if you'd like to get a better feel for what's going on with this I value and what it's doing, maybe we forget about the turtle for a moment and just ask Python to print I. And down here you see that I starts at 0, 0, 1, 2, 3, 4, 5, 6, 7, and then the loop is completed. And so you can see that that loop has done something 8 different times. And those values, 0, 1, 2, 3, whatever, are all being stored inside this I variable.